Everyone. I hope you're all having a lovely day. Today we're going to discuss an incredibly interesting topic, if not one of my favorites, which is the fourth industrial revolution. So Wisdom already went through Industrial Revolution 1 through 3 with you guys. I hope you watched that video. I'm going to gloss over it really quickly in this video as well, but I hope that you engaged with that. So let's have a quick chat about how you're meant to use this presentation and this lesson, because I don't want you guys to take this as, now that you've gone through this video, you have the full education about how all of these technologies work. So I want you to use it as a baseline understanding of a lot of these concepts. So what I mean by that is use it as a means to understand how it works and a few examples, but I want it to be a springboard for further research. I want you guys to do more research to understand more examples of the applications of the fourth industrial revolution and the politics around it and the philosophy around it. I might host a Q&A where we can discuss a lot of these things, and we can maybe throw in some of our thoughts about how to approach artificial intelligence from a philosophical perspective. But the main aim of this lecture, I guess, is to provide information in terms of the what, providing the content aspect of things, so you know what to do going forward. So let's talk about the first industrial revolution really quickly. So first industrial revolution was from 1760 to 1840, which was caused by multiple things: European imperialism, an agricultural revolution, the emergence of capitalism, a whole lot of things. And the few things that characterize the first industrial revolution would be the steam engine, the cotton gin, and the telegraph. So it's just starting the process of reconfiguring and being able to replicate basic human activities. So that was what the first industrial revolution was about, and it transformed economies that had been based on agriculture and handcraft into economies based on large-scale industry and mechanized manufacturing and the factory system. Then the second industrial revolution is heavily reliant on things like the steam engine, as well as the creation of the light bulb and other forms of electricity. It's I think colloquially referred to as the electrical revolution in some places. So it spanned from 1870 to 1914, and again caused by natural resources, an abundance in labor supply owing to the first industrial revolution, and strong government policies, as well as a wide variety of other factors. So the effects of the second industrial revolution are nearly identical to the effect of the first industrial revolution, with a couple additions. The rapid advancement in the creation of steel, chemicals, and electricity helped fuel production. So those machines that were created in the first industrial revolution through the advent of electricity and the steam engine are now able to be significantly more efficient than they were in the past. And here are a couple of inventions that are part of that revolution: would be automatic signals, air brakes, knuckle couplers on the railroad, and many other things. I do assume and hope that Wisdom was able to go through that with you. The third industrial revolution is the one that I would argue we went through and experienced. I don't know how old some of us are, but for me, I experienced it and it was a fun time. But it's characterized by digitization. So the third industrial revolution is the rise of the internet, if you were to basically think about it like that. It's the creation of the computer, the creation of the smartphone, and so many other things, even communication technologies. So that's really what it was about. So the effects of that were things like air pollution, reduction in biodiversity, water pollution, habitat destruction, greenhouse gases emissions. Because remember, let's look at coal as an example. In order to siphon it as a source of energy, a lot of damage happens to the environment. So the third industrial revolution was very much synonymous with a destruction of our natural environment. Gladly, not even gladly so, but unfortunately so, as we move into the fourth industrial revolution, more computing power is necessary, which means that there's a greater need to use those resources again. So unless we don't switch to renewable forms of energy, we stand the risk of damaging the environment even further. Let's talk about the meat of today's conversation, which is the fourth industrial revolution. And it's been happening from 2014 up until now. So the fourth industrial revolution is, in addition to what's already in the screen, because it's ongoing, obviously it's still being studied, but the biggest advent of it is tailoring the internet to you, and it is tailoring things to you and creating artificial intelligence. So those are the main things that come from the fourth industrial revolution. So that would, and we'll talk about all of these things later, things like the semantic web, things like Internet of Things that's already here, and then stuff like artificial intelligence, virtual reality, augmented reality. Those are all of the things that form part of the fourth industrial revolution. Technology is becoming more and more close to humanity in the sense that we can use it in collaboration as opposed to just using it as an assistant. So, fun fact, this presentation is also co-authored by artificial intelligence, but I want to see if you guys can figure out where I used and didn't use AI. But yeah. So the first portion is understanding the growth of the internet, because I feel like the internet has a similar growth and trajectory to the industrial revolutions itself. So the internet is a part of the third industrial revolution, and a lot of what we can allocate to that third industrial revolution is Web 1.0, which involved basic web pages that used HTML. That's the coding language that's otherwise still used in your web pages, but it was very semantic. It read like a well, not necessarily semantic, but it read like a book. So you open a web page, you can't alter it, you can't edit it. The only person who can do that is the person who created the web page, or otherwise an administrator. So that was what the first industrial revolution, or what the Web 1.0 is about. So you open a web page, something like a menu, something like a document that you can maybe click to open to another document, but it was very much limited interactions with it. And then Web 2.0, which kind of existed on the cusp of the third industrial revolution bleeding into the fourth industrial revolution, but not necessarily that much. That's when we started focusing on user-generated content. So that's the advent of things like MySpace, the advent of things like Facebook, where you are not consuming what Facebook has manufactured, but you are consuming content from other people around you. Things like YouTube happen around this time. I think it's 2005, 2006, can't remember. But Web 2.0 is where user-generated content becomes valid and important. And then Web 3.0 is the semantic web. So what Web 3.0 is looking towards is, firstly, things like tailoring the internet to you. So you get recommendations specifically to you. Users are able to monetize their data. There are things like NFTs now, which we're going to discuss in the next video. And then there's virtual reality and augmented reality, and blockchain technology as well. So Web 3.0 in a nutshell is the internet has developed a degree of intelligence that allows itself to tailor to your needs as an individual. So you're not just looking at user-generated content, you're looking at content that is useful for you, and you are able to perform transactions to a better degree online. All right. The fourth industrial revolution is a data-driven revolution. It is driven majorly on information. So sorry it says 2022. I modified a presentation I did for KZN last year as well. But data is important in the sense that every single creation that's coming of age right now is a creation that analyzes billions, if not hundreds of millions of data sets in order to reach conclusions. In the same way that you are able to do things through receiving information from multiple data sets, your English teacher is a data set, Stembiso's coaching is a data set, Wisdom's coaching may be a data set, your parents are another data set, and you analyze all of this information to process it to reach a reasonable outcome. So that is what is driving the fourth industrial revolution. So what you think about from there is why companies like Google, Apple, Amazon, they have free online storing hubs, right? So this PowerPoint is probably on Google Drive as it currently stands, and Google Drive is free, right? So that is the advent of the fourth industrial revolution, and that's why the data is free, because they need those large data sets in order to train AI so that they can do more with it. So data is also shared between platforms to create a personalized experience. So for example, you may open your TikTok and see videos that are reminiscent of something you searched in your Safari web browser, for example. Or you may have a conversation on Facebook and start seeing those ads on your Instagram, or you may buy something on Takealot, but start seeing more Takealot ads on your Instagram. That is because data is shared between different apps and to some degree between different companies as well. So a lot of data is collected. Some of the data is even unintentional. By unintentional, I mean the people who are receiving the data genuinely have an intention of it, but you don't know that you are providing them with this data. Let's look at something as simple as your credit card companies. So if you pay with card whenever you go to the shops, obviously they'd receive the information of the things that you'd regularly pay for. Why this then becomes important is you are buying diapers maybe every 2 weeks, right? So that company now has the information that you either have a child or you live with a child in close vicinity. Or they have information that you're a chronic alcoholic if you are a person who consistently is buying at Tops, for example. So they use all of this information to create ads that are personalized to you, or for any other malicious means that, I don't know, maybe conspiracy theorists believe in. But a lot of data that is collected in modern times is also unintentional. And when you sign away the end user license agreements to say that they can use this data, you often are not aware of what you are signing over, which I think is super interesting. We're going to have another conversation about security and data potentially on another video. But in terms of where that data goes, it goes to a data warehouse, which is a central repository of information that can be analyzed to make informed decisions. And then once it's in a data warehouse, it goes through a process called data mining. So that's the practice of analyzing the large database in order to generate information about patterns. So say, for example, all of the data for everyone's purchases is in a data warehouse for Capitec, for example. They have all of their users in one specific data warehouse. So from there, they can use data mining, which would include algorithms to look through a lot of this data to generate patterns of people's buying, to generate patterns of what people invest their money in, so that they can create programs that are more valuable to you, and they can create programs that will allow you to spend your money with them more. For example, one consequence of data mining would be Live Better Savings for Capitec. They have partners, I think they're partnered with Bolt and a few other companies, where if you are spending money with them, Capitec gives you like a small percentage of money at some point in time in the form of Live Better Savings. So in order for them to know that that's a deal that makes sense, they have to mine that data across multiple users to figure out that this is a company or this is a particular purchase that a lot of our users make use of. So we might be able to generate more profit if we create a partnership with this particular company or with this particular stream of purchase. So data is super, super important. Even when we're discussing ethics, we're going to have some conversations around the value of data. Let's look at the Internet of Things, which I think is a very, very cool concept. I think it's very interesting. So, the Internet of Things describes the network between physical objects that are embedded with sensors, software, and other technologies for the purpose of connecting and exchanging data with other devices over the Internet. So, it uploads all of this information to the cloud, and data is shared between these devices. It's still obviously developing. So an example of this would be your fridge, which has sensors, notices that you don't have tomato sauce. It will order a bottle of tomato sauce and have it delivered to your house without you even realizing you're out of tomato sauce. So basically that technology, and I'm going to use that example, right? So the fridge has its own set of technology. It's going to go and connect to the cloud or a central repository, which will connect it to maybe another shop. There it can order whatever it wants, but from there it needs to connect to your banking information, where it can buy or use your account to buy whatever is necessary. Then it needs to connect to a courier service to have it delivered to your house. Then it just sends you a message to say, tomato sauce is going to be delivered at time X, Y, and Z. So that is the Internet of Things. It is the convergence of different devices and different networks in order to assist you in whatever you may need assistance in. So there are more IoT applications that we can look at in the coming slides, but simply put, that's how IoT works. All right, let's look at some examples of IoT. There's smart home automation by Google Nest. Then there's health monitoring wearables with Fitbit, connected cars with Tesla, smart agriculture, and industrial IoT. So I'm not going to spend time reading over these things. We only have a limited amount of time. So I want you guys to take the time to read through whenever there is an example slide. I want you to take the time to read through it for yourself and potentially research it more to see if you can get a greater understanding of things that are being presented. All right, let's talk about cloud computing, because I think this is a really also valuable backbone of technology in modern times and the fourth industrial revolution. So the cloud refers to a virtual storage space for information that companies offer to general users or at a price. And in reality, when you upload something to your Google Drive or the cloud or iCloud, it makes it seem as if you're uploading to some virtual space, but in reality, they're just massive hard drives, we'll call them that for now, massive hard drives that are purchased by a company, and you are uploading your data to those hard drives. And computing is the computing is the delivery of computing services, including servers, storage, databases, network, software, analytics, and intelligence over the internet to offer fast, innovative, flexible resources and economies of scale. Cloud computing allows you to use advanced processing power of the likes of Google at a particular price. Let's break down what all of that means. So what the cloud is, again, central storage space. But beyond that, it's not only for storage, it's also for computing. A lot of you guys play online games as well. So when you're playing those online games, the processing, or at least majority of the processing, is not happening in your computer. Majority of the processing is happening on the internet through the drives, through the processing units that your Google and your Amazon obviously have access to. Why that's a comparative advantage in computing is that they are able to buy equipment with specs that you simply cannot afford. Specs meaning specifications. So the number of processors that their CPUs have may not be the same as yours. Their ability for their CPUs to do things like clock multiplication, all of that, it may be significantly better than your computer's ability to do that, and more often than not it is. So you are able to rent out a portion of that in order for you to be able to use it. You pay just to use it for that particular purpose. That is the advent of cloud computing. And if you want to look at and I find this example super cool for cloud computing, open a document on the internet, right? If you're a person with an incredibly slow computer, open a document on the internet as opposed to opening on your Adobe Acrobat Reader. use the search function. If you're using the search function on the regular Adobe Acrobat Reader, you may find that it's incredibly slow if it's a document with more than 1,000 pages. But if you open it on your browser, you may find that it does it fast and it does it at a normal pace. That's because the computing is not only being done by your computer when you open your browser, but it's also being done by the internet, in inverted commas, which refers to the processing units by Google or Microsoft, depending on the browser that you choose. So that, in essence, is what cloud computing is. It's very necessary for the fourth industrial revolution, or all of the machines we're creating right now, because when it comes to a lot of them, they require a lot of processing power. And if technology ought be accessible, then it is impossible for each individual to be able to have the machinery to produce that processing power for each of those devices. So it often, or for each of those services. So it often makes more sense to rent it out from places like Amazon or Google, as opposed to buying like mega CPUs or multiple disks for yourself. So yeah. Okay, we've gotten to the fun bit, which is artificial intelligence. And here we're going to discuss what it is, how it works, everything in between. So artificial intelligence is the simulation of human intelligence processes by machines, especially computer systems. Specifically, applications of AI include systems, natural language processing, speech recognition, and machine vision. Natural progression of industrial revolution and technological advancements. That's essentially what AI is. Because if you were to think of the first industrial revolution, what that was about was simply creating a system that can do human behavior potentially faster, like a simple human task. Then in the second industrial revolution, when the steam engine and when electricity was invented, it means that whatever was created in the first industrial revolution could now work at a significantly faster rate than ever before. Then third industrial revolution, that electricity is being used to create systems that operate at a split second. That is what the internet is. That is what computers are. That is what central processing units are. And now we're in a space where we've progressed to not only doing things faster, but doing things better. So what I mean by that is it's no longer menial tasks, it's also tasks that replicate human thinking entirely. And the earliest successful AI program was written in 1951 by Christopher Strachey, later director of the Programming Research Group at the University of Oxford. I just like to throw in facts on slides just every now and again for no reason, for the sake of completeness. I don't know, one of the two, but yeah. Let's look at the difference between strong artificial intelligence and weak artificial intelligence. So definitively, each one is very much self-explanatory. It refers to the degree to which it's able to execute the tasks that are specific to artificial intelligence. So with weak artificial intelligence, it's not as good at emulating human behavior. With strong artificial intelligence, it's significantly better at emulating human behavior. So weak AI is AI that implements a limited part of mind, so it's very narrow and it's focused on one narrow task. Strong AI is able to construct mental abilities through processes, functions, and it's essentially multi-segmental. Weak AI cannot fully emulate human identity, as well as strong AI is able to focus more on emulating the fundamentals of what it means to be a human. Weak AI cannot perform artistic or higher intellectual tasks. In contrast, strong AI aims to be able to pass the Turing test. We're going to talk about the Turing test in a second as well. And then there are a list of examples of weak AI, but there's not many of strong AI because, again, it's a very controversial statement to say that we're in a place where AI is even strong. So there are not many universally agreed upon examples of what strong AI is. The disadvantage of weak artificial intelligence is that it has an inability to think out of the box, whereas the disadvantage of strong artificial intelligence is that it requires a lot of processing power. We already spoke about this in the previous slide. Advantage is with weak AI, it requires little processing power, and the advantage with strong artificial intelligence is that it is able to emulate human behavior. Basically, the advantages and disadvantages are converse to each other for weak and strong AI. Let's talk about how AI works. And I think this is super interesting as well. I'm sorry if you're going to hear me say that a billion times over during this presentation, but it just really is, guys. It really is. But when we're speaking about how AI works, we're essentially referring to machine learning, which is a subfield of AI, which is defined as the capability of a machine to imitate intelligent human behavior, so to imitate the ways in which people learn. AI systems are used to perform complex tasks in a way that is similar to how humans solve problems. So machine learning, in the simplest form, it is the AI or the machine version of absorbing information done with the human brain. And in order to understand how that works, and how to understand how AI works, we have to understand how we process it. So we're going to talk about neural networks, but first we're going to do a little bit of neuroanatomy. I promise you it's going to be some very, very basic neuroanatomy here. So on one side, I have an image of the brain, and then on the other side, I have an image of a neuron. So we're not going to look at the anatomical structure of a neuron. It's not important to my conversation. So a neuron is the single processing unit of the brain. So what happens with a neuron is that it receives an impulse, it processes the impulse, and then it essentially transmits that impulse to the next neuron so that it does the same thing. That is what a neuron does. And your brain is a collection of neurons. It is a large network of neurons. It is the OG biological neural network. And in order for you to understand how your brain works, I want you to think of how or what happens when you see me, right? So you've arrived at you're not at training. Let's say you're at the supermarket and you see me. Yeah, you see me there. So the first thing your brain is going to do, it's going to receive a sensory input from your eyes that will be converted to a stimulus, transport to your brain. All of that's unimportant. But when it gets to that first neuron is going to try to differentiate me from all other objects. So at neuron number 1, we're going to understand that I am a human, right? That's what's going to happen at neuron 1. Then from there, we're going to go to neuron 2. At neuron 2, we're going to look at all of the different humans that you know in order to ascertain which human am I. Then you're going to go, this is Thembis. Now that you've identified who I am, we're going to go to neuron 3. In neuron 3, we're going to look into who is Thembis to me and what relationship do I have with Thembis. Right. That's where it's going to get confusing because you're not used to seeing Thembiso at a supermarket. You're used to seeing him in a classroom or maybe over a Zoom or hearing his voice, booming from your speakers, whatever the case may be. So that's what's going to happen. And once you've gone through that, your brain is going to adjust to say that he is a human. This is neuron 4, so he can be anywhere humanly possible. Then we're going to get to neuron 5, where we look at how do we speak to and address Thembiso, generally speaking. Then we're going to move on to the output of saying, hello coach or hello Thembis. That was an entire process where each neuron had its own responsibility insofar as the processing of everything. And that is a biological neural network. Surprise, surprise, computer neural networks operate literally the same. So a neural network is a series of algorithms that endeavors to recognize underlying relationships in a set of data through a process that mimics the way the human brain operates. In this sense, neural networks refers to neurons either through organic or artificial in nature. It seeks to emulate the human brain and how it functions, and it consists of 3 nodes: an input node, multiple hidden nodes, and an output node. It allows AI to recognize patterns and solve problems. So what I want you guys to think about here is the same conversation we were just having. So what AI will do, and these little nodes here, these little bubbles are where the algorithms are. It's where the processing happens. So and in these little bubbles, you're just doing super, like it just does some really easy maths. But really easy maths combined together makes a really complex process. Let's say we want to discuss how does the AI that recognizes or that recommends movies to you on Netflix work. So you're going to register for Netflix. That is our input layer, right? You're going to put in information. I'm going to say I'm a black male who is 21 living in South Africa. So it's going to take that information and then it's going to go node one. It's going to go, what do black males watch the most when it comes to our, when it comes to our service? Then it's going to drum up a list of things or a list of shows and movies I should watch, which is really simple, right? It seems it's simple maths to do to figure out whatever that is. If you do IT, you probably already know the algorithm to figure out how to do that. Then from there, it's going to go, what do South Africans like watching? That's what node number 2 is going to do. And then node number 3, or just take this as it is. So each demographic is going to a different node. Then the last node is going to cross-reference what these nodes have done, and it's going to cross-reference them with what have I watched in the past. So based on what I've watched in the past and all these really simple algorithms, it's going to create an output of this is what I think you should watch, or these are your recommendations for Netflix. Same thing for and this is such a grim one, but with lethal autonomous weapons recognizing people or recognizing the people that you should shoot at within a warfield. So input 1 is you receive an image of someone's face. Then from there, node 1 is going to use just basic geometric patterns to recognize the difference between a dog and a human and whatever, to see that you are a human. Node 2 is going to look at other identifiers to see what kind of human you are. Node 3 is going to limit it to what are the humans that are fighting for us and against us, and do you fit the category of humans fighting against us? Then, now that we're on the last node, there's an output of we fire. So again, super grim example, I'm really sorry about that, but that is essentially how AI works. Now, that was the simple example of a neural network, right? But your chat GPTs and everything, they use a collection of neural networks. It's a lot more complicated than that. And that's what we would call large language models. So they're advanced AI system with millions and, if not billions of parameters. So they train on massive data sets. So what they're doing here is not only looking at what actions have people done before, but also what has the process been in the past. And they are learning from your inputs and your feedback consistently to fine-tune their process. And then we're going to talk a bit about generative adversarial neural networks. So what these are, or they specifically represent how images are created in this thing with AI. So when you use your Bing AI image generator, or you use any image generator, this is essentially how it works. So there's a generator, right? The generator has analyzed billions of images along with their tags to figure out what is what, essentially. It uses patterns and lines to figure out this is what a human is, that's what a dog is, whatever the case may be. And then through learning all of those things, when you say draw an image of a dog, it's able to create it and recreate it. And then that is the generator. Then there's the adversary, which is the discriminator, or the police in this case. Yeah. So what the discriminator does is that it checks if the image that was generated by the generator is an AI generated image or a real image. So if it can tell that it is an image that is generated by AI, it puts a stamp of not fake on the image, and it gives feedback on why it's a fake image. Then from there, your generator has the responsibility of looking at that feedback and modifying it. After it does that, the discriminator or the adversary does the same thing again. It analyzes it to check Can I tell whether or not this is a real or an AI generated image? It produces feedback if it's a fake image. Then the generator does the same thing again. It'll repeat the process until the discriminator can no longer tell between a real image and an image generated by AI. That's when you're going to get that consequence of an image that was AI generated. It's a really, really interesting process. Another way images are generated is through diffusion. So what happens with diffusion is that an image, a normal functioning image, they add noise to it, right? This is noise. And once they add noise to the normal functioning image, then they will train AI to be able to restore the original aspects or to remove the noise. But they will gradually increase the noise to the point where the image is basically unrecognizable, right? So once it's unrecognizable and the AI is still able to regenerate it, then that means the AI understands how to create particular images based on prompts and how to restore images. Then it uses that information from its training phase to regenerate or to synthesize images from basically nothing, which is really, really interesting as well. It's an interesting way to try and learn the generation of images. Right, cool. And then again, some really simple examples of artificial intelligence. There's OpenAI, DeepMind, IBM Watson. More examples, read. And then, of course, I linked some more interesting examples for our students. Let's talk about your boy, Alan Turing, and the Turing test. So I'm not going to spend too much time on this. It's just a really simple test that's meant to assess whether or not a machine has reached a level where it's indistinguishable from a human. So a strong artificial intelligence, remember, like we spoke about earlier on, strong AI seeks to be able to pass the Turing test. That means you should not be able to distinguish between strong AI and a regular human. So it involves a human judge interacting with a machine and a human through a text-based communication. So at the point at which the judge cannot consistently distinguish between the machine and the human based on their responses, then the machine is said to have passed the Turing test. So yeah, that's just about it that you need to know for the Turing test. Then quickly, let's talk about virtual reality, which is very much a self-explanatory term. Virtual reality, or VR, is used or is a use of computer technology to create a simulated environment which can be explored in 360 degrees. Unlike traditional interfaces, VR places the user in the virtual environment to give them an immersive experience. So this is usually experienced through VR headsets such as Oculus, and the reality is entirely computer generated and allows people to interact using avatars. How do they generate this entire reality out of nothing? Remember, we just spoke about how AI is able to, or the mechanism behind AI generating images, videos, and everything in between. So this uses that system. It also uses that system to predict how to react, right? So it's going to look at its large data sets when you turn left, and then it's going to go, what have people done in the past when they turn left? Then it's going to obviously apply that fix. That's why it's an environment that continues to regenerate itself and it continues to emulate a real world space. Yeah, it's another very riveting idea to tap into. And then applications include video gaming. I think that's the most common one, in creating a digital world such as the metaverse or the Twilight Zone Season 2, Episode 2, and for entertainment and media. Yeah. Here are some examples of virtual reality projects. Please be sure to give them a read and go over them. Then there is augmented reality, which is, I guess, different from virtual reality in the sense that it is not a completely new world. It is a world that is added onto your real world. So the picture there is, I think, a good representation of it. So examples of augmented reality would be even something like filters, where it uses input from the real world and the actual reality, and it adds onto it. It augments reality. So yeah, that would be basically how augmented reality works. And then again, some really cool and interesting examples of augmented reality. By the way, just because I'm going over the examples, I'm not explaining them because I think the slides do a good enough job to explain them, and I don't want to waste time just reading slides for you. But you should read these slides yourself and research them further should you desire to. I think all of this is incredibly interesting. Then there's the conversations of the ethical concerns around technology. So data itself is biased. Data is an intrinsically biased thing. So what do we, make of pattern recognition of biased data? So for example, if there was AI that was involved in policing, right? So pattern recognition AI would have picked up on the pattern that Black people disproportionately are more incarcerated, convicted, and commit crimes than any other race. The consequence is it will use that data set when it's assessing whether or not it should treat a Black person like a criminal. So that level of bias and justice and race and gender becomes very, very important. And then there's the environmental impact, which we've already discussed reasonably so. Then there's the socioeconomic divide. It is to say that all of these technologies are incredibly expensive. Because of that, it is limited to people who have the financial capabilities to use them, and it's not accessible to everyone. The lack of accessibility then becomes the problem with the data biasness, because if only a certain group of people are able to access the data, are able to access the system, then they will be the only people that are feeding the data. Hence, that system will now be biased and prejudiced against people who are unable to afford it, who are unable to use it. So that's why the socioeconomic divide is a problem, specifically in relation to how we discuss AI. All right. So thank you everyone for hanging out with me for 42 minutes of me just randomly discussing AI. There will be more videos under the technology subject that I will maybe go into better details on the subject. Please feel free to let me know if you have any questions, and who knows, maybe we'll even host a Q&A a bit later.